So now we have the logical operators, which are a set of operators designed to let you chain together true or false expressions. Typically, early on at least, we would chain together things like yes or no questions, like is A less than B. And we'll see some contrived examples, but in the code examples we go through later, we'll notice that it's very useful for allowing us to ask questions like, we could ask a question like, is A less than 6? But what if I wanted to ask a question that was more complicated, like is A inside of a particular range? Is, for example, A less than or equal to 6, and is A greater than or equal to 0? Or I could ask questions where I'm not requiring both conditions to be true, I want either of them to be true. For example, is A, so I should say this was a case of needing and, is A, let's try, greater than or equal to 6, or is A less than or equal to -6? So is A any value outside the range between -6 and +6? And we know already that we can ask these questions. We can ask individual pieces of this. So if we have the ability to chain them together with, the operative word being and or, then we could build up more complicated conditions just by chaining together basic pieces. And so that brings us to the logical operators. And there are 3 operators in this family. And they are called logical and, that's this one, logical or, that's this one, and then a strange one, a unary operator. It's sort of the logical equivalent of a negative sign, and it's called logical not. I've got the names here. And so one key thing to understand is that we have to use, for logical and, for example, 2 ampersands. Don't use 1. There is an operator that uses only 1 ampersand. That's why we have to use 2 for these. The operator with 1 ampersand is bitwise and. And I mentioned earlier, we don't want to touch the bitwise things in this course. And it's a strange one, so make sure you always use 2 ampersands. On an exam or an assignment, you could lose marks for using only 1 ampersand, even if the code appears to work. So the logical and operator takes 2 operands and then evaluates whether each operand is true or false. And remember that the operand A is considered true as long as it isn't equal to 0. The result of a logical and is true if both of the 2 operands evaluate to true, both of them. If either operand or both operands evaluates to false, the result of logical and is false. And I guess on the other side of that, we've got an operator called logical or. So logical and is represented by 2 ampersands, which shouldn't surprise us. There isn't such thing as an ampersand. So what we use for logical or is this. So this symbol here is a vertical bar. You can probably get it because you have a key on your keyboard that looks sort of like this. It's the backslash. Pressing shift and backslash probably gives you the vertical bar that you want. Sorry if the drawing was sort of bad. So logical or also evaluates both of its operands, whether they are true or false. And then the result of logical or comes back true, which of course means 1 in this context, if either or both of its operands are true. So if A is true but B isn't, then OR gives us true. If A is false but B is true, then OR gives us true. If A and B are both true, then OR gives us true. The only time OR ever gives you back the value false is if both A and B evaluate to false. Then there's logical not. Logical not evaluates its operand, only has 1 operand, it evaluates it, and then gives you back the opposite truth value. So if A is true, we read this as not A. If A is true, not A is false. If A is false, not A is true. So the logical not operator flips the truth value. Just like the comparison operators, the result type of a logical operator will always be an int. And the value of that operator will always be either 1 or 0. It's true that, of course, I could ask the question 6 and 10. And it turns out that the result of this would come out to be 1, because 6 is considered to be true, and 10 is considered to be true because it's not 0. And if we have true and true, the result will be the value true, which is 1. So remember that the operands don't have to be 0s and 1s. They could be any integer, and we know whether to determine if an integer is considered true or false. But the output, the result of a logical operator will always be 1 or 0. So let's try a few examples of this. Okay, so here's likely the most common use, at least early on, of the logical operators. What I've done here is I've chained together two comparisons into one operation. And I think semantically what I'm trying to ask with this chain is it true that the variable a is between 5 and 9 inclusive? So is it equal to 5, 6, 7, 8, or 9? The way I ask that is I say, is a greater than or equal to 5 and less than or equal to 9? You also should notice that if you want to ask if a is greater than or equal to 5 and less than or equal to 9, you still have to fully write the question, is a greater than or equal to 5? Is a less than or equal to 9? You cannot try and write something like this. Quite a few people make this mistake. I don't blame them, but you can't do it. So you can't stick the and without having separate questions that you're asking. You're combining together two questions. This doesn't work. So you can't stick the and on the right-hand side of some other comparison. Instead, you have to ask two separate questions. Is a greater than or equal to 5? Is a less than or equal to 9? And then chain those two separate questions together with the logical and operator. The other thing I want to observe is that these brackets are actually not necessary. The natural order of operations of these operators means that these two do get evaluated first in any case. But you might notice having the brackets sure makes it easier to figure that out. So leave the brackets in for now. We'll talk about what happens if we have no brackets next week. It gets a bit strange. So let's answer the question. Is 6 greater than or equal to 5? And the answer to that is no. Well, let's see. Okay, so 6 greater than or equal to 5. Yeah, that's true. Okay, good. So there we go. And the result is an int. So it comes out with the value 1. All right. Is a less than or equal to 9? Okay, so is 6 less than or equal to 9? The answer to that is, of course, also yes, and it's also an int. So now I'm asking the question 1 and 1. And remember, the result of the and is true, or 1, if both of its operands are true, or that is not 0. And so the answer to this is 1. And it is also an int. What comes out of an and operation is always an int. Okay, here's a use of logical or. So we'll first answer, is a equal to 187? Okay, so does 6 equal 187? I don't think so. So that's a 0, and it is an int. And then, is b less than or equal to 111? So b is 10. Is 10 less than or equal to 111? I think so. So that's 1, which is also an int. And then we're asking the question 0 or 1. If either or both of the two operands are true, the result is true. So this over here is true, which means the result is 1, which is an int. And here's the use of the logical not operator. So the logical not operator gives us back the opposite truth value to its argument, to its operand. And this is the operand here, the thing in brackets. Okay, so let's see. A is equal to b. Let's take a look. 6 equal to 10. Well, the answer to that question is no. 6 is not equal to 10, so this is a 0, and the result is an int. And then we say, okay, so wait, what is not 0? Well, we take the truth value, so this is false, and we flip it. So false goes to true. So the result of this whole thing is true, or 1, which is also an int. And here's a strange one. So I'm applying the not operator to a value that is not 0 or 1. It's 10. And I should also illustrate, just to be clear, maybe it's obvious from the way I've written it here, but we would do the not operation first before we can evaluate the and. Okay, so what is not b? So what I want is not 10. We know that it's going to be an int because the not operator always gives me an int. And what it does is it takes the truth value of its operand and flips it. Okay, so 10 is considered true because it's not 0, which means what comes out is false, or 0. And then a is 6, which is considered true. But our question is, I've got 6 and 0. But we know that and only gives us true if both of its operands are true. So the result of this is false, and it is an int. And here's a and b just by itself. So a is 6, b is 10, and we know that logical and gives us back true if both of its operands evaluate to true. And they do, because neither of its operands are 0. And so this comes back with the value 1, and that's an int. And so using logical operators to chain things together, and the best example probably is this one here, where we're asking if A sits inside of a particular range. We might occasionally ask questions, though, like this. Is A equal to 187, or does B happen to be less than 111? Although this is a little bit more contrived. The usual use case is things like this, maybe things like this. In this course, though, it's really important that we know how to take even a really bizarre situation. This is a bit bizarre, because if I ask, is it not the case that A is equal to B? That's exactly the same as if I just write, I think, the much simpler, A not equal to B. These two are identical, but we need to know how to evaluate both forms. And in this situation here is a bit weird, but if we don't understand how these operators work, it's going to be really tough to churn through more complicated expressions later in the course.